As I mentioned, welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Vadum with Atlanta Functional Programming. Today we'll be discussing a very nice database-independent API library that I found by Fukamachi, the guy who wrote such awesome Common Lisp libraries like CLAC, Caveman, Ningle, amongst many others that he also created. He also tried to start a little Lisp initiative called CL21 too, amongst other things. This library is called cl-dbi. And today we'll be discussing some of the APIs, and hopefully I can show you that it's actually a very nice library for you guys to try out in your applications. Before we get started, I wanted to mention that today's content will be on GitHub and the Atlanta Functional Programming Organization GitHub repository for you guys to see and check out. If it isn't there, please ping me on this YouTube link and I will make sure that it gets updated. I just pushed in a couple of changes in last night, but those of you who are trying to get ahead and probably even leverage the GitHub repository to follow along, some of the newer changes that I made this morning are not there just yet. So we'll get through those, and then hopefully we'll actually post them so you guys can try it out and experiment with it. So what is cl-dbi? cl-dbi, as I mentioned, is a very nice, simple API to interact with different relational databases. You may have leveraged other database libraries in the past with Common Lisp. A couple of examples of this is, say, like some fairly heavyweight things like Elephant, which gives you a very nice meta object model to an ORM style library that leverages the mop to actually go and create what are called persistence classes and hides a lot of the standard database operations that most people would normally write SQL for. This kind of is comparable to ORM libraries that you may have used in other languages like Python, like forgetting the Python one that's kind of SQL Alchemy, or in Java, like Hibernate and so forth. Other libraries that are around there too as well, more specific to like different databases. The ones that I'm most familiar with are like Postmodern and so forth. That gives you interaction with the Postgres database. What cl-dbi does is it takes a very different, more of a lower level approach than a lot of these libraries, in that it provides a very basic API for you to create database connections, manage them, create the ability to write prepared queries against a schema and so forth. Amongst that, it also provides some very nice thread-safe connection pooling, so that you can have a set of managed connections that you can use between different threads inside your multi-threaded Lisp applications and so forth. I'm going to go ahead and go through the basic of the APIs, mostly focusing on SQLite 3 today, just because it will handle the majority of what the API has, but it will cover the majority of what you would probably use on your day-to-day basis. At the same time, I will kind of give you an overview of some of the architecture stuff, so that if you wanted to go and leverage some aspects of the API for different databases and try to make sure your application's database agnostic, you're aware of those. To start with, I'm going to go ahead and load up my, hold on one second. For some reason, I think I just killed my Lisp process. So give me just a minute here to get back to, do I have a REPL available? Don't believe so. Okay, so let me just go ahead and start another REPL. Okay. 1 second. Sorry, have to try that one more time. There we go. So we'll load up a basic tutorial project that I've created that will show some of these off. Let me just go ahead and show you the ASD file here, just so that you're aware of what this looks like. So to start with, all you need to do to actually leverage cl-dbi is to load cl-dbi. DBI has a dependency into your system's definition. There isn't any additional dependencies as far as I can tell. Internally, it does pull in a couple of things related to database drivers. We will account for those as we go on. But to show what database drivers are actually available, you could just simply run dbi list all drivers. Let me just have to go into the 1 second. I need to go into the package that actually leverages it. Okay, dbi list all drivers, and this guy will, mention the drivers that you've actually are currently using. You could also see if it has a specific driver for your, whether you're using SQLite or Postgres or whatever. You could also write your own driver. There's a driver API that cl-dbi provides to allow you to hook into other databases, and it's just a few functions that you just need to go ahead and match to your particular database of choice, and we'll go through and enable it and create a driver object that can be then leveraged by the DBI engine. To connect to a database, it's pretty simple. I'm going to show you an example of this. I have in db schema.a. You have what's called DBI Connect. DBI Connect takes in two arguments. One is the driver name, because obviously, since cl-dbi is a database independent API, you have to mention what the driver you want to leverage in order for it to make the appropriate, database specific connection strings to connect to that particular database. And then you could then specify appropriate arguments, like, for example, if you're using SQLite 3, the database name is actually not a typical database that you would use for the host and whatever. Instead, it would be just the file name. Once you do that, you can go and connect to your database. So I'm going to go ahead and show you something that I did earlier, which is in. I went ahead and abstracted this out just so that you can see clearly what the different commands are, and then we can go through them one at a time. So let's go ahead and connect to our simple database here. We have a database file called users. We're going to create a simple users table. Okay. I'm going to show you some schema files just to kind of mention how I normally interact with databases. You might have different practices, but I normally keep the schema itself that I'm going to be leveraging in a separate file. So with that, I created what a schema.sql file that just simply has a dummy users table. You see it has a first name, a last name, an age, and an occupation. You can, use this as like maybe even a members list. You can even, add, say, for example, although I won't do it now. You can add like email address or whatever on there. This file is leveraged by is read in has a single string, and then to execute it in a cl-dbi, we have this function called there are two functions to actually leverage it, but for creation statements, at least from reading the documentation, you can use essentially like a prepared query to actually leverage this. This is also what you would use to write prepared queries for select statements. We'll go into that in a minute. But what the prepare function takes in is obviously the connection that you're leveraging, and the SQL string that you're trying to execute on, and then what it returns is an actual query object. Now, instead of actually running this function, I'm just going to go ahead and leverage get files here that I wrote earlier. This is just a convenience function to read the entire contents of a string that I wrote, just so that we can actually leverage reading out this this file. So I'm going to head and exported this. So this should be available now. Let's do this. cl-dbi get file contents. All right. So now we need to specify our schema file, and you will see here, if we just simply run, don't do this at home, kids, but you know, since even though it's not exported, this is we can access this guy here as users database schema. What this does is it will what are you talking about? It's unbound. Hold on. Thought I ran all this correctly. Okay, let's see. What, did I mess something here? Okay, you know what? Just for the sake of expediency, I will grab this line here. And use okay. So this obviously returns just the string content. So I'm going to go ahead and add the query string in a parameter here. Okay. So to run this guy, all you need to do is simply do query. Let's go ahead and run this without actually assigning it to anything. We will take our connection string, which is in connection, and we will pass in our query string to it and see what it returns. You'll see it will return a query object. Now, this has been prepared. That means that it has not yet been executed, as you guys know about normal prepared statements. For those of you who aren't familiar with it, what this does is it goes into, it will, if this was an actual prepared string, it will go ahead and assign database specific member variables to any variables that are available in it, and it'll allow you to then execute that by passing in certain parameters. And we'll see that when we run some select statements with this style. But let's go ahead and execute on this guy. What this now does is internally it tells cl-dbi's driver to go ahead and run this query against the SQLite engine obviously executing the create table statement and generates the appropriate table for that statement. And this now enables us to now insert some data into this. To do this insertion, you have basically a nice option in DBI called do SQL. This is normally what is used by DBI to actually allow you to weird. Why is it's not showing up here? This is should show me the hold on one second. My completion is not acting up the way I expect it to. Do dash SQL. Okay. This guy takes in again, the connection object that we just created and the string, but it allows us to create a template almost. It'll allow us to create a simple users template that specifies positional arguments for that will correspond to the columns that we're trying to insert into the database. So here I'm creating a simple insert. As you can see, they'll take in a first name, last name, age, and occupation for a user, and I could pass in, say, John Doe, 34, and 34. And let's say that this guy is a student. All right. It's going to be a PhD student. And when we run this, it will go ahead and, syntax here. Why is it near L name? I must have messed up my SQL. Did I mess up my SQL? Insert into users. This should have generated. Go here. Hey. Okay. 1 second. Wondering if I have to actually specify. I've seen this done with one parameter, but I never actually. This should have worked with multiple arguments, but let me see if this actually fixes it. No name syntax error. Oh, I'm an idiot. I just realized what I did wrong. I forgot to add commas. And one more. One second, let me try this one more time. This should have, oh wait. There we go. That's it. So please remember your commas inside your query statements. I'm an idiot. Sometimes I'm messing that up. What happens is when you run this this command through do SQL, what it does is it goes behind the scenes and prepares it, creates a little implicit transaction goes behind the scenes, and then executes it. What it returns is obviously the row count of the number of rows that have been inserted for this. And you could keep going with this, adding multiple users. So let's just go ahead and add a bunch of users in a dummy fashion. Let me just do it this way so that I can do times x. Let's say let's add about 10 users, and let's go ahead and go ahead and make a dumb name for this individual called egg number A, and take in the value. And all these guys are going to have the same age, let's see, except for the first one. Increment f and multiply x and multiply by that. Okay. So we now have a bunch of users in this table. To query all of them, and there's a couple of things we need to do. Mainly, we need to write a simple select query. I'm going to show you two ways of dealing with it. One, technically, you could use cl-dbi do SQL to actually run a select star against this guy from users. Weird. Why? And it will return. But this looks like a bug. Hold on a second. Let me just read this. Only runs I'm gonna go ahead and do the prepared one. See what happens. Prepare the connection, select star users. cldbi execute. All right. And package db does not, oh, sorry, dbi. And what it returns us is a query. Now we could do a row count on this guy, and we should get, oh, sorry. If you want to know what the results were from DBI, your query, like the number of results that returned, you should be able to run dbi-row count. But for some reason, I'm having trouble actually doing that. 1 second. Did I mess that up? That should have worked. Oh. I messed it up. Okay, 1 second. I have to run this guy again. Execute, and let's set the results up here. Assign it to an actual variable. Now let's do a row count on results. I messed that up. Massive. Okay, should have worked, but. Oh, right. Okay. My apologies, folks. I misunderstood when row count. I thought row count can be used for selects as well, but it looks like you have to actually fetch everything from the query if you're running selects. So let's go ahead and do this and fetch each one of these row collect. You could see that what was generated by the DB results is in the query object. It's fetching them. It acts like a cursor behind the scenes. So what that means is a DB cursor, for folks who aren't familiar with DB cursors, database cursors are kind of like pointers to the rows inside of a table. So you could go and fetch the next row based on the particular result set that you get. DB fetch takes in and fetches them one at a time. There's also fetch all, which I don't think I can run on the same query object twice, but we'll try this anyway. And you'll see that, because again, I ran the fetch ahead of time. It ate all the results and then retrieved them. But so let's go ahead and run our query again here and run fetch all this time, and you see we'll get the same results. You can also write prepared statement that takes in arguments. So let's say that we define let's say we want only those rows that are greater than say 50. Okay, we see we have 3 rows there: Jack, 4, 6, and 8. We could create a prepared statement. Let's say prepared get by age. Let's call it that way. And we do dbi prepare. And let's say that we want to do select star from users where let me just get my notes here up here. Yeah, where age is greater than some number. All right. This will, hold on one second. Gotta remember my earmuffs. Okay. Here is one thing that I messed up here, and that is that I forgot the connection. Okay. Now, when we want to run this, what we do is we simply run dbi execute on our prepared statement. But this allows us, if you notice in the execute signature, that you could pass in individual params. These are positional params. These are not keyword parameters. So you can't actually specify name equals this out of order. You have to actually specify it in the order in which the query expects it to. So let's say that we want to grab things that are greater than, let's say, 30, okay, just to make things a little different. Now, if we do a fetch all on the results, you'll see that we got everything from, greater than 30. If we wanted to, and you just want to do what I did earlier, which is just temporarily run the results and then grab everything, you could actually combine these into a single statement, obviously, and do the same thing, which is just simply dbi fetch all, and it will go ahead and run the things. But the point is the prepared statement is compiled in the SQLite side. It's just a simple lookup on the SQLite side and runs it. And you're keeping track of that prepared statement that you've compiled has a pointer so that you can easily reference it. Are there any questions so far? Okay. Clearly, we have an open connection here. We need to be able to disconnect from it. So to disconnect from the database, you have a disconnect. For folks, who are looking at this, say, this isn't very Lispy. We're doing a connect, we're doing a disconnect. There is a with connection in cl-dbi that I'm currently not illustrating here, just merely because I wanted to show you all the different ways that you can leverage connect and disconnect and have a little bit more control over your API. You may certainly go ahead and do so, especially in the cases of, like, say, SQLite, to use connect. In fact, you also have the option in cl-dbi to use connection pools inside your application. Fukamachi wrote a function called connect cached that would keep connections available for folks, so that when you're needing to grab a particular connection and the connection is available, it'll just return it to you. And internally, it manages a connection pool that for each time you request one, it will create a new connection only if there aren't any available. I'm not showing that right now because I don't have a multi-threaded example for you to illustrate that. When I commit this code into GitHub, I will certainly have an example of that. On top of that, we have the ability to do a with transaction that also gives you the ability to, commit rollback transactions normally. You have also the ability to do this manually if you really wanted to, using begin transaction, commit, and rollback. So you can write your code that way. I'm going to go ahead and, to show an example of row count, just what I was showing earlier, I'm going to go ahead and do a quick update here so I can, in the queries that are being run. This way it'll be a little easier. Again, I'm going to leverage updated results. Okay. Let's say that we wanted to run an update on, because we noticed in our database here that really this way it'll be a little easier. Does anybody have, are they muting? Okay. If you have any questions, let me know. I just heard my voice in the background here. So let's go ahead and write a very quick, oh wait, I just disconnected from it. So first, before we get started on this example of row count and stuff, let me show you one more thing. Let's say you disconnected from the database like we did just now. If you wanted to see if a connection is alive, we have a ping option that gives us the ability to check to see if we're connected or not. So let's go ahead and connect ourselves again. And now you can see that if we ping the connection, it returns us the connection that it's connected to, which in our case is just really the file name. For folks who are using Postgres and MySQL, my understanding is if you do a ping on the connection, it could give you just a T, like saying the connection is alive, or a nil. In SQLite's case, from what I've seen, as you saw, it has illustrated here, it's always returning you the actual file name itself. So if you're thinking this might be what you're going to be retrieving from Postgres and MySQL, with the exception that it will replace the file path with, say, the connection string, that's not true. It's probably just going to give you the connection handle true or false based on whether or not the connection is available. So let's go ahead and run a quick thing on updating some stuff. So I'm going to go ahead and do just a quick updated results that runs a do SQL that updates users. Let's see, what should I do? Set occupation equal professional software engineer, where f name equals John. Okay, so it's going to, if you notice, it's going to only run it on the first result. So once again, make sure that we pass in our do SQL statement the connection object. We run it, we get update result. Now, if we just run dbi row count on updated result, you'll see, okay. So that is, my apologies, I'm really messing things up. You have to first do the following. This is not on do SQL. Do SQL automatically returns the results and prepares single state. This is mainly on executing, if you do a dbi execute on a prepared statement, which is a which will return a query object for you. Let me change this guy just for that. There we go. Oh, okay. I misread that signature. Let me go and read this. It's not actually showing up. Okay, that's the reason why I'm sending in the query object instead of the actual result. Okay, so let me go ahead and change this to a different example. Let's say age is greater than 20. They're all professional engineers. So now, if I run, we'll see that the connection from the previous result, previous query, was 5. So what this allows you to do is you can write unit tests. The main reason I'm showing you row count is you can write unit tests to make sure that if there are particular conditions and particular rows that you need to that need to be modified, and you know the maximum number of them, you could certainly write your unit tests to leverage this. Really, for the most part, as you can see from my day-to-day, I rarely use this function. I've used the other ones, but the main day-to-day stuff that you would end up leveraging is do SQL, execute, prepare, um, fetch and fetch all, depending upon whether I want you to grab all the data or get it at the same time, and with connection. So showing you all this, how one would go about and leverage this library. Um, the way I'm currently leveraging it, and you could see that I'm writing my own. This is kind of how I tend to leverage, tend to be writing this library, use this library. I tend to write a little bit of an abstraction above cl-dbi, mainly just so that I can, hide behind some of the database specific things in DBI from the users of my API. And I write like domain objects that matches in some cases one-to-one to table structure. So you might be thinking, oh, this sounds a lot like you're writing your own ORM. It's not at all. There are specific reasons why you'd want to write this kind of API, mainly that it allows you to have a little bit more control over exposing your query layer and your schema from the rest of your users, and allows the rest of your users, more importantly, to just know Lisp. They just need to look at your specific database API for your application and leverage that. So you see, as an example here, I have a users table that the user example that I just showed earlier in by hand in the command line. I wrote kind of a Common Lisp, a standard way of defining a class, setting up some CRUD operations to actually go and interact with the database. Certainly right now I have not yet completed this because I didn't have enough time before the discussion today to actually complete it. But we can certainly move some of the stuff that I've showed earlier, like for example, the insert statement that we wrote here. You could certainly see this guy here as being run into using my new API that I'm writing that takes in. Let me just go ahead and pass this in. Writes. So to illustrate this, let me go ahead and paste that guy. No. And so you can just see that this is just a simple abstraction that allows users to only interact with the Lisp API and not DBI at all. Obviously, it has its advantages and disadvantages from doing this. You may want to write, for example, the ability for a person to do arbitrary queries, like writing like a front end to it, like a query editor for folks to actually interacting with your database. Then in that case, you may want to leverage DBI directly instead of writing this kind of like API. But this does give you some flexibility as we go through other databases and database APIs to go and remove or even update your internals, and still have users' code be compatible. This is all standard software engineering. I'm sure most people are aware that this might be a good approach, but there are particular cases where this style may not be appropriate. Now, before I finish up, there's a couple of things that I wanted to mention. Earlier, I brought up that you could write your own driver. This is something I have been investigating myself, and I am going to give you kind of like what I've seen so far, just so folks are aware. The one thing is the driver API has been documented. It says that you need to first write. So if you want to write your own database driver, uh, on top of the cl-dbi, you mainly need to implement two things. You need to create a subclass of dbi driver. This guy is in, if I'm not mistaken, there's a dbi driver, but I have to go and double check that again. I will write this in and post this up online once completed. The other thing that you need to do is you need to implement make connection and disconnect, obviously, and how to execute your query. So this is what he calls execute using connection. These are the only three methods that you need to implement if you want to use his vanilla implementation of the rest of the API. So prepare, fetch, using connection, and so forth. If you want to, though, there's a bunch of other functions, and I encourage you to look at the cl-dbi documentation to actually look at what other methods can be overridden. But to give you a little bit of a sneak peek, you can actually override, say, do SQL, how you handle inserts, updates, and deletes, how you deal with escape strings, how you deal with fetching. So if you have a different fetching strategy than what is default being used, you can certainly change that. There are many other ones that are available to dealing with overriding functionality so that you can have a better performing driver. I'll let you guys read the DBI documentation for that. Finally, DBI provides a very nice thing that I have yet to really play around with, that I was hoping that we would have some time to do, and that is the what he calls execution hooks. These guys are the ability to essentially attach functions to the DBI runtime that while the drivers are doing their thing, it can actually run these functions in your Lisp environment for say things like logging and so session management and so forth. So I'm going to go ahead and give one simple example that he already provided. One is he calls it's called the simple SQL logger, which just does nothing more than, from what I read, it goes ahead and logs the SQL statements that are being executed in your engine. So you can attach this guy into SQL execution hooks. Before we do that, let me first show you what this guy's defaults are. If I remember correctly, it was empty, but I could be wrong. Yeah, it's empty. So we're going to go ahead and push DBI simple SQL logger, and now we have a logger attached to it. Let's go ahead and run our earlier update example here. and just change them to programmers. You can see that it will automatically generate the SQL statement has a comment and throws it into the REPL. If you have additional functions that you want to run, like say you want to run a time query on how long a particular query takes, and you want that attached, you could certainly add to this list of functions, to this list of hooks, certain metrics that you could then run while you're executing your queries. One of the beauties of doing this is for folks who have dealt with different database management systems in the past, you could see that one of the beauties of doing this is that you are running these functions in your runtime. You're not actually adding additional hooks inside the database management system. This is kind of nice because of the fact that you're dealing with the driver performance, you're dealing with the management, you're not adding additional configuration in your database configuration that you have to maybe take out when you're throwing your database configuration into production. These are the kinds of things that you have to kind of think about when you're engineering an application. And having this kind of ability to just dynamically add stuff to it, just like other logging frameworks and other monitoring frameworks, is kind of a good thing, especially in the Lisp environment. So that's all I have today. This is, like I said, a very simple API that I thought would be nice to show off, that I've come to actually enjoy, although as you saw, I kind of botched up a couple of things related to using one piece of the API. The rest of the API is fairly straightforward. Like I said, read the documentation for additional advanced features. I hope to see additional drivers. Right now, the available drivers for DBI are Postgres, MySQL, and SQLite 3. That isn't to say that you could hook up Maria, SQL Server, and so forth, because again, like I said, if you just subclass DBI driver and write those overridden functions, you can essentially write a driver for DBI pretty easily. Hoping to see some of those are available for folks to use. Are there any questions?
Yeah, Ram, two quick things. First, is this model? I'm assuming this is modeled off the Perl DBI API.
As far as I know, it is, but I can't say for certain because it's been a while since I touched it.
Yeah, me too. That's why I was wondering if you know. The other question is, this closure. I know a big thing for a while. I don't know how much people use it anymore, but Korma was like a kind of a big thing because there's like a SQL DSL library, so you can, instead of using strings and stuff, you could do SQL to DSL, and I thought there was something in Common Lisp that was equivalent. Like I thought it was like SXQL or something like that. Have you used anything like that, or do you know of anything like that?
I have not used SXQL in the closure side, and I'm trying to investigate to find an equivalent on the Common Lisp side. And if there isn't, project idea is something like Datomic, which gives you this nice ability to hook into like your queries in such a way that you could write, like, I think, data log queries against your data sources. I'm not familiar of a Datomic equivalent in Common Lisp. That's kind of what I've been kind of hunting down. I found DBI as being a very nice low-level convenient thing for things that I tend to do on my day-to-day basis when I write SQL and say like Python and stuff, that I was like, okay, I can use this because I know how to use this. but ideally having something like Datomic or
Datomic is its own kind of complicated trickery.
Yeah,
okay.
that's not a simple base. That's got all. It's based off all timestamps. Right? All the data is timestamped as it's going in.
Yeah,
So
yeah.
it's not a relational database.
Yeah.
Yeah, it's a deductive database.
Yeah, it's more of a it's graph database. At least that's how I've been using it more recently. But it's not a SQL database. It's good for graph stuff. It's good for like event source kind of stuff. It's good for
So you'd say it's more NoSQL than but
it's not that either. I mean,
It's
NoSQL.
sort of like Prolog, where you specify your rules, and the relationships are automatically computed for you.
Kind of.
That's the deductive databases, and it's based off of Prolog, so.
Yeah, well, Datalog is.
My understanding when I first heard about Datomic is that it gives you kind of like the ability to choose your own adventure, right? It gives you, depending upon how you want to model your data, it'll allow you to do that.
Yeah, well, so Datomic, it's a 3-tuple database or a 5-tuple database, depending on how you want to look at it.
Okay.
Right. So like it's an entity attribute value database.
Right. Okay. So it kind of follows the Allegro graph kind of like family.
Yeah.
Okay.
It's Allegro graph style.
Okay.
And similarly, you query it using a Prolog DSL because that's what's good for querying entity attribute value databases.
Right.
Datomic isn't a 3-tuple database because it has 2 extra columns, one being the transaction ID and the other being whether or not it's an assertion or a retraction. And that lets you that's the way that you avoid ever removing anything from the database, basically. You basically never actually delete things from a Datomic database, or you archive old data, but you don't actually delete it.
You never delete it. Okay.
You're always asserting new facts, and some of those facts might be that old facts are no longer important, but that is itself a new fact, is the idea. The fact that some old data, some old knowledge no longer is valid is a new fact in Datomic, right? And the usual way of writing constraint-based queries kind of abstracts over that, but you can very easily do queries against like, hey, I want to know if knowledge has been added to the database that looks like this kind of thing since this transaction, right? And you can do all kinds of craziness along those lines. It's a very flexible little query engine, but the database itself is really quite complicated, and implementing it performantly is even bigger headache. And then just implementing the Datalog query engine is itself yet another massive undertaking.
Right. I mean, I'm not trivializing the challenges of doing it. It's more of a wish, a wish list, of seeing it, because I could certainly suspect, or at least I'm hypothesizing here, that and again, this is me comparing Common Lisp to JVM, so take it for what it will. Especially Steelbank Common Lisp for that matter. I would think that it could run faster potentially.
So maybe, but honestly, a lot of the overhead in Datomic has very little to do with the performance of the query engine itself, and a lot more to do with the performance of the data structures they've got, and also to do with the all of the networking stuff they're doing, right? Because one of the big things about Datomic,
but I will point out to this because the guys from Franz actually had a very nice talk about how at least some. This is earlier on before they added some additional features into AllegroGraph on how they ended up having to write certain performant data structures for their storage engine to implement the graph database internally. And a lot of times, what they ended up having to do is and again, this is because they have Allegro Common Lisp specific system APIs that they could leverage. They had to escape actually the Lisp virtual machine to do some.
I mean, like, Datomic is implemented itself atop usually another SQL-based server. Not always. You can host it in a few different ways, but Datomic is actually often hosted atop. It can be hosted atop another SQL server. In which case, the things that they're storing are these massive, basically byte arrays.
Right.
In the SQL server, right? So that gives them the same basic idea, right? They do these kinds of high-level queries against that SQL server to grab the ranges of their indexes that they're storing in the SQL server to grab the right byte arrays, and then they're just pulling those byte arrays in, and then they're processing that, right? So
Right.
they can accomplish a similar kind of thing. They're not really bound to the JVM's garbage collector.
Okay. But that's a level of indirection, though, that you have to account for then, right?
Sure, but there's a level of indirection in what Allegro's doing, too, when they're touching foreign memory.
Right. You have the standard, yeah, of course. But but and I understand that, but that's easier to the way, instead of handing it off to a third party SQL server, right? Because I've seen other graph databases attempt this, and often, the performance kind of of certain types of queries, especially when you're talking about graph queries, right?
Sure.
It could be particularly bad given the
So the other side of it, right, has to do with the specific architectural design that Datomic has, which allows you to really cleanly parallelize it.
Right.
I guess I'm kind of arguing around you here.
Yeah.
To put it, my point is that I don't think the JVM matters very much in the end, because where Datomic derives its performance is your ability to spin up basically as many reader nodes as you need, and they all have their own copy of a local index. And so they're running queries entirely independently of each other. And the bottleneck in Datomic is actually the transaction system, because that has to be run on a single server in order to ensure atomicity.
Right.
But as far as like querying the database is concerned, you can parallelize that really cleanly, and so you end up.
Right. But that's the hardest part of any database, right? The storage engine, the actual storing of the individuals, and making sure that it's going to be a potential bottleneck.
Sure.
Not necessarily the reading of the database, because you can do certain optimizations, right?
I mean, it's not just the optimizations though. It's because of the design of the database being add only, being append only. They don't have to worry about synchronizing all of the different reader nodes in the cluster.
Okay.
Like that's part of the design, right? And so the peers, I think they're called, run actually entirely independently of each other and just passively listen for new datums to be added from the by the transactor. And then queries are run almost entirely locally.
Okay.
Right.
Yeah. Mm-hmm.
So,
Which means you can just.
Sonic has full reader modes running in parallel.
I'm having a lot of trouble understanding you.
Michael, you're
Oh,
gonna
I
have
just
to
asked
speak
if
up.
you said you could run.
Hello?
Hello? Hello?
Can you hear me?
Yes.
Now we can hear you.
Okay, sorry about that. So you were saying that Tonic lets you run as many reader nodes in parallel as you want, and is that
Yeah.
correct?
Yeah.
And so it just has to, run writes on a single thread, for ethnicity, like you said.
Correct.
How does it deal with, like, reading parts of a write, basically?
So in Datomic, the idea of a transaction is actually first class. Transactions are actually entities in the database. And so the way that actually works is so the transactor is always running it locally, right? And then each of the readers have their own cache of their own cache of the index, right? And what happens is the transactors basically are just each time they complete a transaction, they send the new datums out to all of the readers, right? And then the reader only starts making use of the datums in that transaction once it's received all of them.
Interesting. Okay.
Yep. Actually, when you connect to a peer, a reader in Datomic, you get a view of the database that doesn't ever change because the transaction number you were on when you requested that view of the database is part of your connection. You can step it forward whenever you want. You can say, "Hey, I want to receive, the new datums now. Give me the next transaction ID," right? But when you make queries against the database, you're always saying, "I'm querying as of this transaction ID," right? And so you're always viewing whole transactions.
Right. Well, that's because the whole thing is based off like the STM model that the data structures are based off, isn't it? I mean, basically they just threw a timestamp on there.
Yeah.
And then
Yeah,
that
'cause
becomes basically like the transaction ID essentially.
Yeah, exactly. Yes. Every fact has a transaction ID, a timestamp on it. Yes. And you're always querying as of a particular transaction ID. And actually, you can query as of old transaction IDs. You can explicitly say, "Hey, I want the last transaction that occurred on this date. I want a view of the database as of that transaction." It'll be slower because it usually has to go and fetch bits of the index that it doesn't have cached. But you can do that, and the queries just work. And actually, you can even do queries against multiple views of the database if you want to, and have some of your constraints be on some views of the database and some of them be on others. Or you can, if you're running on the closure side, you can construct filtered views of the database even, where you have some predicate that filters out database facts that you don't want included when you're querying over that view of the database. And you can then do all kinds of craziness with that. There's a project that I'm using right now where I'm not using DataScript in Datomic in particular. I'm using the in-memory implementation of it, re-implementation of it called DataScript.
DataScript. There's another project called DataScript.
Yes.
Okay.
Yeah, DataScript in the Clojure world refers to basically an alternative to Datomic that runs entirely in memory and uses entirely in JVM data structures.
Okay.
And actually they're like Clojure data structures. You can just write a DataScript database out to file really cleanly, but it has its own implementation of the entire query engine. And so for that, there's some tricks I do in where I run queries where I have both a view of the entire database and a view of the database where any facts older than a particular ID I've filtered out. And that lets me do things like, hey, I want to, have some of my facts only match when they're new facts, effectively. And I can do neat little tricks like that. It's a brilliant little system. But my point is just that, like, Datomic isn't bottlenecked performance-wise by the JVM, except for the transactional operations, adding new stuff to it, where it is slower. But it's slower also because the system as a whole, right? The things you can do in a transaction in Datomic are actually rather complicated, and the generating new datums in general is rather complicated, and so you end up, no matter what, the transactionality, the adding new facts to a Datomic database is slower than a SQL database, but reading stuff out, even for like remarkably complicated queries, can be quite a bit faster.
Well, that's because in a SQL database, if you recall, right, you're going to have to do certain types of optimizations ahead of time to speed up queries, like writing indexes,
Yeah, actually,
doing the data layout.
in Datomic, they maintain 3 separate indexes, one by entity, one by attribute, and one by value.
Yeah.
And they actually just duplicate all of the datums across those indexes because the datums themselves are tiny.
Right. That actually is the same approach that a lot of graph databases take.
Yep.
They end up they create up to, like, in some cases, 6 indexes behind the scenes for the different permutations before you can actually go and run it. So you can run your queries pretty fast.
Yep.
The interesting thing is that I didn't realize that this might be an interesting a side thing that I should mention is I didn't realize that there was a SQLite kind of like thing for Datomic called DataScript, where you can run it in memory. And the reason I confuse Datomic as having some SQL support is because if you read Datomic's product offering,
Yeah.
it mentions that it could do analytics using SQL. And that kind of like is like, okay, does that mean you can also model using relational stuff, or is it a different approach? So I'll be honest, I've only read the documentation on it just to cursory see how I can actually leverage it. I never actually had a chance to use it directly because at the time Datomic was still in flux, and now I just haven't had a chance to. But
fair enough.
This it's interesting though, just because, again, going back to what it offers in terms of data log, in terms of its model of actually doing distributed queries. I'm kind of curious, well, if one were to write this in pure Common Lisp, what would be, the differences in terms of both performance and in terms of having the same guarantees? How hard would it be is the question, but as with anything, you could do anything in any language, right? That's kind
Yeah.
But yeah, are there any other questions? I see Judd is on the line there. Do you have any questions, Judd? Looks like the dude's not paying attention. Okay.
No, I'm okay. Thank you very much.
Okay, cool. Well, if that's it, then stay tuned for next week when we get started on hopefully some mock stuff. If something comes up, obviously let me know. I'm available on chat.lisp.cl, on Discord, on the Functional Programming Slack channel. There are many avenues to get to me if you have any ideas for talks. Please let me, if there are particular comments about this particular talk, post them on the YouTube video. I will go ahead and address them as soon as I can. That's it. Have a lovely day for anybody who's driving out there on the road, and for folks who are tuning in. I will see you guys next week.
See you then.
See you.
Bye.